Okay. Now we have already gone through the physical quantities. We have got fundamental quantities. We have got derived quantities. We come to understand the unit system of units: CGS, MKS, FPS, and SI. Now we will discuss the physical quantities. And if we talk about the physical quantity, here in physics, we are having, again, we can have two types: scalar quantities and vector quantities. Scalar quantities and vector quantities. Now what are they? So if we go through the scalar quantities, its simple definition is it has only magnitude. It has only magnitude, no direction. Now in physics, we are having magnitude as well as direction. So if we talk about the scalar quantities, here we are having magnitude and no direction. Magnitude and no direction. Then it is a scalar quantity. Suppose for example, I say it is a distance. This is a scalar quantity. Mass, which is in kilogram, it has no direction. Direction, only magnitude is there. Speed, it is also a vector quantity, a scalar quantity, and etc. That we are going to discuss in later on in coming lectures. But only we need to know about the scalar quantities, what are they, and similarly for vector quantities. अब हम जब वेक्टर क्वांटिटी की बात कर रहे हैं तो वेक्टर क्वांटिटी सिंपल डेफिनेशन it has magnitude as well as direction both, as well as direction both. Means vector quantities giving us the direction and magnitude both. If we talk about the displacement, we are going to discuss the displacement. Displacement is having magnitude as well as direction both. One. Another, velocity. Velocity is going to be. Then force is there, acceleration is there. They come under the category of vector quantities. Okay. It gives us the direction. So if we go through the direction, how we are getting the direction? If I says from the board, I am taking this board or this wall as a reference. Now there is another word for reference. A reference point. If we take this, say for an example, it is your x-axis, it is your y-axis, or we can denote it in terms of, say, it is your east, it is say your west, north and south. In x direction and y direction we are having this point which we call it as an origin. Origin is a point from this is originated, this is originated, this is originated. Both x-axis and y-axis perpendicular to each other. दोनों एक दूसरे के perpendicular है. फिर इसमें एक point note करने वाली बात है कि यहाँ से यदि हम चलते हैं तो we are always taking 0 0. इस डायरेक्शन में जा रहे हैं तो ये क्या हो रहा है? ये पॉइंट क्या हो गया? इस x के लिए रेफरेंस पॉइंट हो गया. Similarly, this wall is as reference for me. If I am saying I am 5 meters away from this board, means there is a reference point board. So it is giving us the direction and magnitude as well as. So this will be the displacement for me. And if I say only 5 meters, there is no direction. फ्रॉम वेयर, कहां पर मैं खड़ा हूं, किसके रेफरेंस में खड़ा हूं, उसको हम यहां बता नहीं पा रहे, वी कांट रिप्रेजेंट दैट। सो यहां पे यदि हम इस पॉइंट को रेफरेंस ले रहे हैं, इफ वी आर मूविंग इन दिस डायरेक्शन, से इट इज अ पॉजिटिव डायरेक्शन, हमने ले लिया। अब इसके अपोजिट डायरेक्शन में यहां से इस डायरेक्शन में जा रहे हैं, तो वी आर टेकिंग इट एज अ नेगेटिव। Similarly, if we are moving in this direction from this point, it is a reference for this. I am moving in this direction, say. Okay. So here reference point is very important. So reference point is, it may be anything. If we are moving towards the school from home, from our house, house is our reference point. We are going to the school. We are moving away from the house 5 kilometers away from the house. The school is 5 kilometers away from the school. It means it is giving the direction. The direction of the school, which is 5 kilometers away from my home. Okay. Similarly, that is the reference point. If we are talking in terms of school, school will be the reference point. So it is important. Why it is important? Because it will give us the state. अब स्टेट गया, तो यहाँ पे इन टर्म्स ऑफ फिजिक्स की में हम इसकी बात करें यहाँ पे, तो यहाँ पे देयर आर टू स्टेट्स, वन इज रेस्ट, इफ somebody is here, it is not moving in this direction, in this direction, in this direction, in this direction, means it is at reference point. There is no movement or there is no displacement, there is no distance covered by that object. So we can say it is in rest. Similarly, if somebody or some object moves from this point in any direction, here it is, we have taken x direction, it is a positive one. If I can also take it as a direction east, here I have taken the south, here I have taken west, here I have taken north. So if we go through this direction, means I can say we are moving 5 meters away or 5 kilometers away from reference point towards east, towards north, towards west, towards south. So this is the reference point. It may be wrong. This is the reference point. Okay. So here, so state, it is a reference point is also giving the state, and another one is motion. Now, if it is at rest, so what is rest? If you see through it, rest, no change in position. No change in position with reference point, no change in position with reference point. This will give the state of the rest. It is giving the state of rest. Now if we go through this motion, change in position, now we are moving in this direction. It may be positive, it may be negative, it may be in this direction, it may be in this direction. We will be putting some arrow that we are moving towards this direction. So change in position, with reference point. But also we have to take into consideration the time. No change in position with reference point with respect to time. Also, similarly here, with respect to time. So state again, rest, no change in position with reference point with respect to time. Rest, motion, object is changing its position with reference point. If we have taken this reference point, then there is a change in position with the reference point with respect to time. So it is giving you the rest and motion. Okay. Now another term will come into picture. Now rest is there. Change in position with reference means if object changes its position, definitely it is going to be in motion. Now if it is in motion, what will happen? If no change in position with reference point with respect to time, okay, but change in position with reference point. Suppose if we are taking it again, okay, what we are having here? This is the reference point. If we are moving in this direction and say 5 kilometer covered, it is a length of 5 kilometer covered by an object. No direction. It will give the distance. Means we can say this is initial position. We can call it as an xi and we can call it as xi. So the difference of these 2 points will give the distance covered. So distance covered will be given by xf minus xi. It is initial position. We can call it as an initial position. इसको हम initial position कह सकते हैं और इसको हम final position कह सकते हैं. ठीक. So distance covered is given by final position minus initial position 5 kilometer covered. Now I have given you the unit distance which is not giving you any direction. No direction. No direction. This is no direction is there. No direction is there means it is a scalar quantity. It is a scalar quantity. Now the unit we have got this, but its unit is meter. Meter. SI unit is meter distance. So distance which we can understand, हम इसको इस प्रकार से समझ सकते हैं कि जो फाइनल पोजीशन और इनिशियल पोजीशन का जो डिफरेंस आ रहा है वो हमको क्या दे रहा है? डिस्टेंस कवर्ड दे रहा है. डिस्टेंस कवर्ड इज नॉट गिविंग यू एनी डायरेक्शन. ओनली वी से 5 किलोमीटर इज कवर्ड. वेयर, इन विच डायरेक्शन? किस डायरेक्शन में किए, कहाँ पे किए, किस रेफरेंस पॉइंट से किए? यहाँ पे रेफरेंस पॉइंट भी नहीं है. इनिशियल पॉइंट, दो इनिशियल पॉइंट इज अ रेफरेंस पॉइंट बट देयर इज नो रिप्रेजेंटेशन और नो इंडिकेशन. तो यहाँ पे हमको क्या मिल रहा है? डिस्टेंस मिल रहा है. डिस्टेंस इज अ स्केलर क्वांटिटी है जिसमें कोई डायरेक्शन की बात नहीं है, सिर्फ मैग्नीट्यूड की बात है. और मैग्नीट्यूड हम बता रहे हैं 5 किलोमीटर. ये उसकी यूनिट हो गई, एसआई यूनिट हो गई डिस्टेंस की. ओके, नाउ सिमिलर वर्ड दैट इज डिस्प्लेसमेंट. ये हो गया आपका डिस्टेंस. अब यदि हम यहाँ बात करते हैं डिस्प्लेसमेंट की, तो डिस्प्लेसमेंट क्या होगा? डिस्प्लेसमेंट क्या होगा? तो डिस्प्लेसमेंट डिस्टेंस कवर्ड in a given direction. In a given direction. Again we are taking this. We are talking about displacement. Reference point is here. We are taking it as an initial point. It is in this direction. It is a positive one. So displacement will be again given by xf minus xi. But if we have taken it as a east or some reference point we have taken, say from this point we are moving towards the east, or say it is towards the west, or say towards the north or towards the south. So the least distance covered, one thing is there, least distance covered in a certain direction. This will give the displacement. This will give the displacement, and displacement is also having the SI unit, which is meter. Meter. SI unit is meter. Now displacement is a vector quantity. Displacement is a vector quantity. Means it is giving us the direction, magnitude as well as direction. Vector quantities are what? What are the magnitude plus direction. So what we have got here? Magnitude plus direction, displacement, xf minus xi. Now if this displacement may be positive, may be negative, may be zero. Suppose if you are moving from this point to this point, say we say it as a 5 meter, and if we are moving in this direction, opposite to the direction, so this displacement, say at this distance which is covered is 2 meter for an example. So 2 meter will be the negative one. It will be the negative displacement. So total distance, total displacement will be 5 minus 2, that is 3 meter. It will give you the 3 meter. Okay. So displacement is negative. Positive if we are moving in this direction, this is positive, and if we are moving in the direction opposite to the direction of the previous movement, then it is going to be negative. Now if you are coming to this point again at the reference point, so distance displacement will be 0. Displacement is going to be 0. Why? 5 meter plus minus 5 meter. You covered 5 meter in this direction. You are moved in the direction opposite to the direction of the movement, that is negative displacement. So total displacement which we are going to have, it is 0. So displacement may be positive, may be negative, and may be 0. Now if we are moving in this direction from here to here, say you started moving from here to here, say 8 meter. From here to here it is 8 meter. Now this will be the minus 1. Again we can have displacement 5 minus 8, it is going to be minus 3 meter. So this is again a negative displacement. Okay. Now if you are moving in this direction, for an example 5 meter, again you are moving in this direction. Say, no, we are taking it as say example, another example we can have here. So we are moving in this direction, say 3 meter, and in this direction, say 4 meter. For a convenience, I have taken these digits. Now, what will be the displacement now? The question is that. So, if we take a point joining it, this is a final point, and this is the reference point, our initial point. So, minimum distance covered will be the displacement. So, this displacement will be given by 4 square, because what we are having a right angle triangle, and using Pythagoras, what we are going to do, 4 square plus 3 square, which is, I said A, it is say O and it is say B. So here I am going to have OB square, that is going to be 16 plus 9, which is equals to 25. OB square, OB is equals to 5 meter. Okay. So this way we can calculate the displacement.